And welcome back, and it's the Corbett Hire plus 5 a day for the 18th of March, and let's just go straight to the first question. Right, so a drinks dispenser holds 8 litres of fruit. Okay, juice, I was going to say fruit alone, to the near, oh okay, it's another bounce question. So 8 litres to the nearest litre, 9 is the litre above, 7 is the litre below, so therefore it's going to be between 7.5 and 8.5 litres. Each glass holds 200 millilitres to the nearest 10 millilitres. So 10 above is 210 and 10 below is 190. So that's 195 to 205. And then it says work out the greatest possible number of glasses that can be filled. Well, the greatest number of glasses, so G for greatest and U for upper, is going to be the most amount of, the most amount of fruit juice, which is going to be 8,500 millilitres, in other words 8.5 litres in millilitres, and divide that by the number of millilitres in the smallest cup, which is 195, and that's going to give me, well, 8500 divided by 195 is 43.589. What does the question say? Work out the greatest possible number that can be filled. So filled is going to tell me my answer is going to be 43. Good question. Nice question. Next one. I think we've seen one like this before, haven't we? So make M the subject. So your method here is basically going to expand any bracket. So MR plus MP is equal to HR minus MR. Then I'm going to move everything that's an M to the left-hand side. So that's going to give me, oh, what am I doing? M the subject here. So that's going to give me M R plus P plus R, in other words, this R here, is equal to HR. R plus R is 2R, so I'm going to tidy up the left-hand side to give me 2R plus P is equal to HR, and then I'm just going to divide. So therefore, M is equal to HR, or RH, doesn't matter, divided by 2R plus P. And that's it, question done. Now, it's a nice sort of clever version of the questions that you might be quite used to, because you have to do a bit of collecting. I like that question. Next one. Shown is a cuboid with measurements in centimetres. Feels like that might be relevant. Work out the surface area. Okay, first step to any surface area, just so you don't make a silly error, is how many faces are there? Well, there's one at the front, one at the top, one at the bottom, one at the side, one at this side, and one at the back. In other words, there's going to be 6 faces I care about. Now, for a cuboid, you probably know that already, but it just means I'm definitely doing the right thing. The other thing about a cuboid only, or at least definitely for a cuboid, is the faces repeat. So it's going to be for the area, it's going to be the area, I'm going to call it the front. So the area of the front is going to be 5 root 3 times root 3, and I multiply by 2 because front and back. And then I'm going to do the area on the side, which is going to be root 3 times 2 root 2. Again, times by 2 because I've got 2 sides, left and right. And then top and bottom is going to be 2 times 5 root 3 times 2 root 2. So that's my calculation. Let's now try and neaten all this up. So I'm going to write it over to the right here. So let's do inside the brackets. 5 root 3 times root 3 is 5 times 3, which is 15. And 2 times 15 is 30. So that's going to give me 30. Again, root 3 times root 3 is 3, times 5 is 15, times 2 is 30. This one here, well, root 3 times root 2 is root 6. Then I'm going to multiply that by 2, which is 2 root 6, and then multiply it by 2 again, which is going to give me 4 root 6. So not ideal, it's not going to be a nice number, but that is what it is. And then finally, root 3 times root 2 is again root 6, times by 2 times 5 is 10 root 6, and times by 2 is going to be 20, which is going to give me 20 root 6. And let's tidy all of this up, and that's going to give me 30 plus 24 root 6. And it says the units, so let's write them down, centimetres squared, because it's an area. Question done. Next question. Okay, algebraic fractions. Now, there's a few ways of doing this. I'm going to do the slightly longer way, but you can jump straight. I'll show you where you can jump to in one go if you're comfortable, but I'm going to do the way where I fix the left-hand side first. So make the common denominator the same, which is going to be 2x minus 1 over x minus 2, which means I need to multiply the left one by x minus 2 and the right one by 2x minus 1, and I'm going to divide all of that by the new common denominator, which is 2x minus 1, x minus 2, and that's equal to 1. Let's fix the numerator. So that's going to be 2x, very carefully because they're negative. So 2x minus 4 plus 2x minus 1 is equal to, and I'm going to move this up to here, which is going to be 2x minus 1 times x minus 2. Now, when I said you could do it in one step, you can go straight from here to here if you're comfortable. Just be careful, silly errors, etc. Right, next one. Let's gather the left-hand side. The left-hand side is 4x minus 5. The right-hand side, expand the brackets, it's going to give me 2x squared. 2x times minus 2 is minus 4x, minus another x is minus 5x, and minus 2 times minus 1 is plus 2. Let's collect everything on the right-hand side, so therefore 0 equals 2x squared. Minus 5x minus another 4x is minus 9x, and 2 plus 5 is going to give me 7. Question is, can I factorise that? Well, because 2 and 1, I'm just going to give it a quick go and then I'll cross it out if it doesn't work. So it's definitely going to be 2x and x. It's a minus in the middle and a plus at the end, so both of these must be minus. And it's going to be 7 and 1. So basically, where does the 7 go? Well, it must go here, because if I multiply the 2 by the 7, I get 14, and that's too far away. So therefore, that's going to be my answer there. That equals 0. Now, what does the question want? It says solve. So therefore, if I solve this quadratic I've just done, that means that either x equals 1 or x equals 7 over 2. Question done. Good question, that really nice question. Next question. Oh, okay, I've seen the word congruent. Right, if this is your first video of mine that you've watched, I'm going to talk to rather than write everything down, because otherwise you just watch me write a lot of stuff. But let's talk about it properly. So ABCD is a parallelogram. It tells me that in the question, which means that these sides are parallel and equal length, as in opposite sides are equal length, not all sides are equal length. Prove that. So I need to be convincing. Prove that triangles ABD and BCD are congruent. To prove they're congruent, I need to show they are either ASA or they are SSS or, was it the one SAS, isn't it? I think it is. This is not a too bad one. I just need to be clear in my reasoning. So what I'm going to argue is I'm going to try and argue that it is an ASA, these are ASA triangles. And the way I'm going to do that is I'm going to argue that these angles here are the same as these angles here, and then also state that the side, so in other words, one of the sides or two of the sides are also equal as well. So there's a couple of ways I can do this actually, thinking about it, which makes it not too bad. All I need to do is I need to state that because it's a parallelogram and therefore BC is parallel to AD, it must therefore be the case that by alternate angles are equal, so alternate angles, don't just write alternate angles, but alternate angles are equal. So therefore, well, let's label them. So I'll call this A, B, C, D. So therefore D. So therefore A equals C and B equals D. So I've made a convincing argument those two angles are the same, which by the way then means that the angles at A and C must also be the same, but I don't need that right here. It must also be true that both triangles share, so I'm just going to write share length or side BD. So I've actually got loads of choices here. I could either argue SSS because I've said sides are all equal, or I could argue ASA because I've got two angles on the side. I'll say SSS, so therefore by SSS, and actually I didn't really need the angles, did I? But I've written it anyway. So therefore by SSS, what am I saying? Triangles ABD and BCD are equal. To some degree, what makes this question slightly harder, it's almost too easy, because obviously they're congruent because it's opposite side of a parallelogram, but it's just again being clear about what you're showing. And that's it. Good mix of questions again today. I enjoyed them today. I like the surface area question that we did in the middle. Nice bit of rearranging. The first question was not too bad as long as you lay it out carefully, and a good solve question in the middle that we haven't done in a while. Let me know how you did. As ever, do like, subscribe, and I'll see you for the next one. Thanks all.